Hello everyone, and welcome back to my YouTube channel. If this is your first time here, welcome. Today I'm back with a new video in my series where we build a production-ready AI agent application from scratch in 7 days. The goal of this series is to deeply understand the different components of such an application by using as few tools and libraries as possible. Whenever we can, we implement things in pure Python. Today we are starting day 3, and the main topic is data storage. Our goal is to build an AI agent application that can learn about users as they interact with the platform. The challenge is to do this in only 7 days and see how far we can get. That's why you'll see time recordings throughout this series. So far, we have completed day 1, where we captured user input, and day 2, where we taught the LLM how to extract user data. On day 1, we built the entry point for user input. We used Gradio to provide a friendly user interface. We also trained a Keras model to classify whether a user input is relevant to our application or not. This is a powerful component in chatbot applications because it helps protect the system against malicious inputs. It also helps avoid wasting time and resources on messages that are not relevant to our use case. If you missed that video, you can check the link appearing now. On day 2, we used a large language model to extract entities from relevant user inputs. We were able to extract information such as the topic, user interests, recent sentiment, and more. Since we want to use this information systematically in later steps, we need to control what the LLM returns. For now, we prompt the LLM to return only valid JSON. This works, at least for now. The link to the day 2 video is appearing now. Today, on day 3, we will start working on data storage. We need to set up a MySQL database to store relational information, and a Milvus vector store to handle heavier data. We'll see how to insert data into these databases and how to query them. If you're a beginner, don't worry. We'll start from the basics, like installing MySQL, creating your first database, creating users, and so on. I also want to mention that I'm not very familiar with Milvus at the time of recording this video. This project is new for me as well, so I'll be learning with you and hopefully from you. We have a lot to do on day 3. I'm starting at around 10 p.m. I had to work today, since I have a full-time job and I'm doing this project on top of that. I think day 3 will be one of the longest days in this series. There's a lot to cover, so let's see how it goes. We're working in a Jupyter notebook. In the first code cell, I have my imports. Then I define some global variables, such as the model path of our wonderful Keras trained guardrail. After that, we load the model into a global variable called model. To classify user input, we need to compute embeddings from the input text. For this, we use the same embedder we used when preparing the training data for the guardrail. This is the multilingual E5 base embedder from Infloat. This is just a reminder. More details about how and why we do this are explained in the day 1 video. Next, we configure our OpenAI client to talk to VLLM. Remember, in this project we use the OpenAI API format to interact with a locally running VLLM server. We don't need an OpenAI API key here because we're running the GPT-OSS20B model locally. What we do need is the URL, including the port where the VLLM server is running. Now comes the interesting part. Until now, we defined a mock database with 2 users, K Tips and Daniel. Our plan is to replace this with a real MySQL database. We're also collecting the conversation history between users and the system. Since this data can grow very large, we want to vectorize it and store it in what's called a vector store or vector database. Let me know in the comments what term you usually use. Let's run everything to make sure it still works correctly. Inside the process_input function, we use the Keras guardrail to classify whether the user input is relevant to our application. The extract_data function is responsible for extracting user information. In the prompt, we tell the LLM that it is an information extractor for a social media simulation, and we ask it to extract key entities from the user input and return only valid JSON, without any additional text. Those of you who watched day 1 will remember that we struggled to get the LLM to consistently return valid JSON. In the prompt, we provide the user input and a list of entities we want the model to extract, such as topic, sentiment, location, and so on. We then invoke the GPT-OSS20B model using the OpenAI Chat Completions API. After that, we use JSON.loads to parse the model output into a Python object. This ensures that we can safely use the extracted data in later processing steps. The function then returns this parsed JSON object. The cache_with_user function acts as our main entry point. It takes the user input, classifies it using the process_input function, and if the input is relevant, it performs an LLM call to extract the information we want to store and use later. In the system_apply variable, we either store the guardrail classification along with the extracted entities, or, if the input is irrelevant, we store a message indicating that no entities were extracted. To record user feedback for each system response, we attach a unique identifier to every question-answer pair. In the global conversation_history variable, we store the question-answer ID, the user message, the system response, and the user feedback, which is initially set to none. In the record_feedback function, we update the feedback field with the reaction provided by the user. But who is the user? This is where our login gate comes in. The user must log in before accessing the application. The login function takes a username and password as parameters. If authentication is successful, the user gains access to the application content. At the moment, this content consists only of a chatbot. Let's test everything once more. I launch the interface and log in as K-tips using the corresponding password. The chatbot appears. I ask an irrelevant question, for example, about the weather in Berlin. The guardrail blocks it, and no LLM call is made for entity extraction. Next, I ask a relevant question, like how to create a post. Now the system classifies the input as relevant and performs an LLM call, asking GPT-OSS20B to extract user entities from the message. That was a recap of what we've built so far. Now we can finally start implementing day 3. We begin by setting up the MySQL database. At the moment, MySQL is not installed on my system. So I open my browser and search for how to install MySQL on Ubuntu. I want to install it using apt. I open the official MySQL documentation and look for the installation commands. Here it is. In the section about installing MySQL with apt, we see the command to install the MySQL server package. This installs the MySQL server itself, the client, and the common database files. I hope most of you already know the difference between a server and a client in software engineering. In simple terms, a server is a program that provides a service or manages resources, like storing data or processing requests. It listens for incoming requests and responds to them. In our case, the MySQL server is responsible for storing the database, handling queries, and making sure the data is safe and consistent. A client, on the other hand, is the program that connects to the server to use those services. It sends requests and receives responses. For MySQL, the client can be a command line tool, a graphical interface, or even a Python application that connects to the database to read or write data. So when we install MySQL, we usually install both parts, the server, which runs in the background and manages the data, and the client, which we use to interact with it. During the installation of the MySQL server, we'll be asked to set a password for the root user. For this installation, I need to reopen the project via SSH, because right now we're inside a VS Code dev container. I want MySQL to be installed directly on my system. You can also install MySQL inside a Docker container, but then you need to make sure that the data is stored on persistent disk storage. I won't go deeper into that here, but let me know in the comments if this topic is interesting for you. We could cover this in another session. Now we are directly in the system terminal. I copy the installation command and paste it here. Since I'm installing MySQL using sudo, the system asks for my password. I enter it and press enter to start the installation. The installer asks for confirmation about disk space usage, which I accept. While the installation is running, we can already look at the next command. The MySQL server is started automatically after installation. We can verify this by checking its status with the command system.status MySQL. Let me copy this command. The installation seems to be finished, so I paste it into the terminal and press enter. And there we go. The server is active and running. Let me clear the terminal. Next, we want to secure the installation. We do this by running sudo mysql_secure_installation. The output starts with securing the MySQL server deployment and mentions that it is connecting to MySQL using a blank password. It also tells us about the validate password component, which can be used to enforce strong passwords and improve security. You should read this part carefully. Remember, our goal is to build a production-ready application. This component checks password strength and ensures that only sufficiently strong passwords can be used. When asked whether to enable the validate password component, I will skip it for now. Next, the tool explains that password authentication can be configured using the alter user command. By default, a MySQL installation includes anonymous users. These users can log in without an account and exist only to make the initial setup easier. In a production environment, these anonymous users should always be removed. When asked whether to remove anonymous users, I choose no for now, since we are still in an early development stage. The next prompt explains that, for security reasons, the root user is usually restricted to connecting only from localhost. This prevents attackers from attempting to guess the root password over the network. When asked whether to disallow root login remotely, I answer no and skip this step. MySQL also comes with a default database called test. This database is accessible to everyone and is intended only for testing. In a production environment, this database should also be removed. When asked whether to remove the test database and its access, I again answer no for now. Finally, MySQL asks whether to reload the privilege tables so that all changes take effect immediately. This time, I answer yes. And that's it. The MySQL server is now secured, at least for our current development needs. Let me clear the terminal again. To enter the MySQL command line, we run sudo mysql. You can see that the prompt now starts with MySQL, which means we are inside the MySQL shell. Here, we can run MySQL queries. Now we can start creating the database for our 7-day AI agent challenge. First, we need a dedicated user. This is the user our application will use to connect to the MySQL server. To create this user, I run a create user command. I name the user agent_user and immediately assign a password, agent_pass. The @ part means that this user can connect from any host. The command ends with a semicolon, and then I press enter to execute it. The output confirms that the query was successful. Next, I create the database. The command is create database followed by the database name. I call it agent_challenge and press enter. The output tells us that the database was created successfully. Next, I grant permissions to the user. The statement grant all privileges on agent_challenge, *to, agent_user, @ with grant option gives the user full access to all tables in this database and also allows the user to grant privileges to others. I press enter to execute the command, and the output confirms that it worked. In MySQL, the command flush privileges reloads the grant tables into memory. This ensures that any permission changes take effect immediately, without restarting the server. Now I can exit the MySQL shell. Next, I test the connection using the new user. I run MySQL, agent_user, p. I'm prompted for a password, and I enter agent_pass. And we're back in the MySQL command line, this time logged in as agent_user instead of root. This is exactly what we want. The user has full privileges for our database, and we don't need to work as root anymore. I exit the shell again and move on to configuring the application to access the MySQL server. Now I want to set up my development container to interact with MySQL. One of my favorite VS Code extensions for this is SQLTools. Let's search for it. Small typo earlier. It's not MySQLTools, it's just SQLTools. This extension supports many popular databases and makes working with data much easier. It saves a lot of time and really improves productivity. And it's open source. I personally find it very useful. If you've used it before, let me know in the comments, and don't forget to like the video. I add this extension to my devcontainer.json file. If you've been following this channel, you already know the procedure. Once it's added, I check the customizations section, and there it is, SQLTools. Now let's prepare our development environment to connect to the database. Normally, database credentials should be handled securely and never committed to source control. But for this video, I'll show everything openly. My workflow is to create a file called .env. In this file, I define all database-related environment variables. First, I set the database server. Since MySQL is running on the same machine, I set it to localhost. In production, or if the database runs on a different machine, this would be the server's IP address or hostname. Next, I define the database name. For this project, it's agent_challenge. Then I set the database username, which is agent_user. After that, I set the password for this user, which is agent_pass. Finally, I specify the port MySQL is listening on. Since we didn't change it, this is the default port 3306. This file now contains everything needed for a successful database connection. Before rebuilding the dev container, we need to tell Docker and VS Code about this environment file. Docker provides a runargs option for this. Using the env file flag, I can point to the .env file we just created. All variables defined there will then be available inside the container. We'll see how to access them later. Now let's configure SQLTools so that we can connect to the database with one click. Inside the settings section of the dev container customizations, I define a new SQLTools connection. I'll add a link to the SQLTools documentation in the video description. For authentication, I use the default protocol. For the server address, I reference the environment variable we defined earlier. Inside the container, we can access it using the container environment syntax, followed by the variable name, in this case db_server. The port is 3306. Next, I set the database name, again using the corresponding environment variable. I do the same for the username and password. Finally, SQLTools needs to know which driver to use. In this case, I select MySQL. Now there's one more important detail, networking. You may remember from day one that we had issues accessing services running on localhost from inside the dev container. Today, we want to access the MySQL server via localhost as well. To make the host machine's localhost accessible inside the container, we need to add a network flag to the container's run arguments. With this configuration, using localhost inside the container will correctly point to the host machine's localhost. Does that make sense? Let me know in the comments. Now we can reopen the project in the dev container. I choose Rebuild and Reopen in Container so that all changes take effect immediately. The new container is now being built. While this is happening, we can already move on to the next step, setting up a Milvus vector store. I open my browser and search for how to set up Milvus as a standalone service. The first result I get is from the official Milvus website, so I select it. This takes us directly to the Milvus documentation. So, what is Milvus? Milvus is an open-source vector database that allows us to store large amounts of unstructured data and perform fast, efficient vector searches on it. This is especially useful for generative AI applications, and it fits perfectly with what we want to build in this project. Let's explore this page. Here, we can see the available deployment options. There are 4 of them: Milvus Lite, Milvus Standalone, Milvus Distributed, and Zilize Cloud. Each option is designed for different scenarios, depending on factors like data size, application purpose, and scale. Milvus Lite is a lightweight version and the easiest way to get started. However, in this project, my goal is to build something closer to a production-ready application, so I'll use Milvus Standalone. Milvus Standalone is a single machine deployment packaged as a Docker image. It's easier to manage than a distributed setup and still offers good scalability for medium-sized workloads. To get started, we just need Docker and then run the provided installation commands. As you can see, Docker is required for this setup. I already have Docker installed on my system, so I'll skip that part. If you don't have Docker installed yet, you can check the link appearing now. I have a short video, about 5 minutes long, where I explain step by step how to install Docker. On this page, there's also a very helpful comparison table that shows which Milvus deployment best fits different application sizes and requirements. Now let's move on to the installation. If you wanted to deploy Milvus Lite, you would follow the instructions in the corresponding section. But we're interested in Milvus Standalone. Here are the steps. First, download the installation script, and then start the Docker container. We'll run these commands directly in the terminal. Before doing that, let's check the status of the dev container rebuild. It's still running, but it's almost done. We need a bit of patience here, since we're rebuilding the container without using cache. While that's happening, let's think about how we want to manage data storage in this application. Remember, we're using 2 types of databases. MySQL will store structured data, while Milvus will store larger, unstructured data that we want to search semantically. To get a clearer picture, I asked ChatGPT how to structure the data for this type of application. My prompt is something like, let's think about how to store the data for such an application. I ask explicitly which data should go into MySQL and which should go into Milvus. I also share my own idea, for example storing content embeddings in Milvus, and then ask for feedback. The response makes a clear distinction. For a social media style AI agent, we need both structured data and semantic data. Structured data is best stored in MySQL. This includes things like user information, user IDs, usernames, password hashes, profile details, and preferences. MySQL is also a good place to store post metadata, such as post IDs, the ID of the user who created the post, timestamps, and similar relational information. Extracted entities, like topics or sentiments, also belong in MySQL, as well as explicit user feedback. MySQL excels at fast lookups, analytics, and enforcing constraints. On the other hand, Milvus is designed for vector data. This includes embeddings of post content, which are vector representations of the text. We can also store user interest embeddings and entity embeddings in Milvus. Milvus is ideal for tasks like finding posts similar to a given query, recommending content close to a user's interest profile, or performing semantic search across multilingual or unstructured text. This is ChatGPT's suggested architecture. We'll see later which parts we actually adopt and how we refine it. Now let's look at how these 2 systems work together. Imagine a user writes, "Love the new Tesla update in Germany." First, the system classifies the input as relevant. Then we extract structured information from it. This is exactly what we implemented on day 2, where we used an LLM to extract entities and return them as JSON. These extracted fields can be stored directly in MySQL. But what about the full text the user wrote? We can encode that text into an embedding and store it in Milvus, linked to a post ID or interaction ID. This allows us to perform fast and efficient similarity searches later. When we want to recommend content, we can query Milvus for vectors that are close to a user's interest embedding. Milvus also supports filtering by metadata, which makes recommendations even more precise. In short, MySQL is great for facts and answers questions like who, when, and what. Milvus is great when meaning matters. Now let's check on the dev container rebuild. It looks almost finished. When I click on the three dots in the left panel, I can see a new item, SQLTools. I select it, and now I can create a new database connection directly from within the dev container. Before doing that, let's quickly recap. In the dev-container.json file, we added new settings under the customization section. There, we defined a SQLTools connection that should use the configuration values from our .env file. What I expected was that this connection would be automatically initialized, but that didn't happen. Let's create the connection manually. I click on the blue button to add a new connection and select MySQL as the driver. I need to specify a connection name, so I check the dev-container.json file again. I see the problem. I accidentally used the database name as the connection name, and I forgot to specify the actual database field. Let's fix this. I add a new entry called database for the database name, and I give the connection a proper name, for example, connect_to_agent_challenge. Now I rebuild the container again. While it's rebuilding, I continue working on the architecture with ChatGPT. It suggests sketching a schema for both MySQL and Milvus. Before accepting that, I refresh the context so the suggestions are more accurate. The dev container is still rebuilding, so we wait. Now it's ready. One more small fix. I replace the Docker IP with Localhost. Let's check again if the connection was initialized automatically. No, still not working. So I create the connection manually. I select MySQL as the driver and enter the connection name. Next, I specify the database name. I copy it directly from the configuration file. I notice a typo, fix it, and confirm that the correct name is agent_challenge. We can double-check this in the .env file. Next, I enter the username, which is agent_user. I leave the password mode as default. Now I test the connection. VS Code asks for permission to use the command panel, since we need to enter the database password. The system prompts for the password of agent_user. I enter it and press enter. The connection is being tested. Success! The connection is established, and I can save it to reuse it throughout the development of this application. The new connection now appears in the SQLTools panel on the left. All I have to do is click the green button, and there we go. I'm connected to the MySQL database we created for this project. You can see the green indicator showing the active connection. I also have a SQL file where I can write and execute queries directly against the database. There's no need to leave VS Code or open a separate terminal. Everything is centralized and much more comfortable. In the SQLTools panel, when I expand the connection, I can see the database structure. At the moment, there are no tables yet. We created the agent_challenge database, but no tables inside it, so seeing nothing here is expected. The same applies to views. Now let's go back to our code, specifically the Jupyter Notebook. To make sure everything works correctly, I clear all outputs and restart the kernel. Since we don't have much implemented yet, I can run all the notebook cells. Now let's look at the next steps. We need a MySQL database to store user profiles. This will replace the mock database we currently have in the code. We also need a vector store, but we'll handle that part later. I paste the existing code and functions into ChatGPT to refresh the context. Then I ask a simple question: what should we store as user profiles? The response explains that, for a social media-like recommendation system, we need two kinds of profile data. The structured data belongs in MySQL and contains factual and relational information. The core fields include a user ID, which can be implemented as a primary key using a UUID or an auto-increment integer. We also need a username and a password hash. We never store raw passwords in a database. Instead, we hash them using a secure algorithm like BCRYPT. Additional fields include the user's email, account creation time, and last login timestamp. ChatGPT also suggests additional attributes for a richer simulation. We'll decide later which ones to include. The second type of user data consists of embeddings, where semantic meaning matters. These embeddings should be stored in Milvus, since it provides fast similarity search capabilities. We'll use them to recommend content by finding vectors close to a user's embedding profile. Finally, ChatGPT proposes example SQL scripts to create tables. It suggests starting with 3 tables: users, posts, and feedback. We'll explore these tables and their attributes in more detail later in the series. We also have an example showing how to create what Milvus calls collections. Collections are similar to tables in traditional databases, but they are designed to store vector embeddings along with their metadata. Each collection defines a schema, including fields and data types, and stores entities that all share the same vector dimensionality and distance metric. This makes them ideal for organizing and searching large volumes of unstructured data. For our use case, we can start with 2 collections, one for post embeddings and one for user embeddings. We'll come back to this later in more detail. For now, let's focus on the MySQL database. I copy the SQL script proposed earlier and paste it into VS Code. The Gradio interface is still running, but we can stop it for now by clicking the interrupt button. I restart the kernel again, since the previous test didn't fully succeed. Remember, we ran all notebook cells after rebuilding the dev container to integrate the database connection. Now it's running again. Let's paste the SQL script from ChatGPT and click the Run button in the top right corner. A new output panel opens in the IDE, showing the execution result. Everything looks fine. Let's check the SQLTools panel on the left. And there we go. Under the Tables section, we now see 3 entries: feedback, posts, and users. All 3 tables were created successfully. If I click on the feedback table, I can see its attributes exactly as defined. The ID, the user ID, the question-answer ID as a string, and so on. Checking the posts table confirms it was created correctly as well. The same goes for the users table. Now let's go back to the Jupyter Notebook. It seems to be hanging. I reload the window and retry. Now you can see that the IDE immediately prompts me to connect to the database using the connection I created earlier. This part is very straightforward. Let's try running all cells again. Now we get output, but also an error. It says that GR is not defined. At first glance, this is confusing, because Gradio is already imported as GR. Let's just rerun the code to be sure. And there we go. The Gradio interface is loading again. Now we can test the application. At this point, we're still using the mock database, so we can log in as ktips with the password defined in the JSON object at the top. Once authenticated, we can type a message. I'll enter a question that is relevant to the application: how to create a post. The guardrail validates the message, and the system extracts the entities. This is our sanity check, and it passes. We can move on to the next step. Before that, I want to quickly recap an important detail. The LLM is now accessible via localhost inside the dev container. This works because we added the run argument, network equals host. To summarize, setting the network to host mode allows the container to share the host's network namespace, which means any service running on the host's localhost is immediately reachable from inside the container. Now let's set up the Milvus vector store. We need Milvus to run as a standalone service, so we do this outside the dev container. I reopen the project via SSH. Next, I paste the curl command to download the Milvus installation script. It doesn't work. I try again. Same result. It looks like we missed an important step. This is a good reminder: don't blindly run commands. Always read the documentation carefully. Let's go back to the documentation. There are some prerequisites that must be completed before running the installation script. We need to execute another command first. I copy and paste it into the terminal and press enter. It turns out we need to install FIO. Let's do that quickly and then retry. Now the initialization starts. Once it's done, we can run the curl command again. This step takes some time, so we need to be patient. It's already 11 p.m., and I can confidently say that day 3 is the longest day of this challenge. There's still a lot to do, but I'm not tired yet. Sometimes, when you're deep into coding and things start to work, you just don't want to stop. It's too exciting. Done. Let me clear the terminal and download the installation script again. Here we are. We now have a standalone _embed sh script in the project directory. This script contains everything needed to install Milvus inside a Docker container. The next step is to run this script. I copy and paste the command and press enter. The installation starts. While this is running, let's go back to the documentation and check what happens after installation. A Docker container named Milvus will be started. Milvus itself listens on port 19530, and ect is running on port 2379 inside the same container. The documentation also explains where configuration files are stored and how to restart the service using the same script with the restart option. Now let's figure out how to work with Milvus programmatically. The next step is to connect to Milvus using Python. For that, we need the PyMilvus library. Let's quickly check what it is and how to install it. We can install it using pip. Since we're working inside a dev container, I add PyMilvus to the requirements.txt file. While I'm at it, I also add a MySQL client library. Instead of MySQL connector, I'll use pymysql. After updating requirements.txt, we need to rebuild the dev container. While it's rebuilding, we can continue exploring the Milvus documentation. I copy the example Python code from the doc so we can test it later. At this point, it's a good moment to recap our goal. We want to set up MySQL and Milvus. We also need logic to insert new user records and, later on, query them. What's still missing is the actual Python code that interacts with both databases. We already created the MySQL tables using SQL scripts. And earlier, ChatGPT also proposed schemas for the Milvus collections. Let's find that part again. Next, I ask ChatGPT for help creating the Milvus collections using Python. The vector store should also be accessible from within the dev container. The first step it suggests is installing PyMilvus, which we already did. Then it provides a Python script that defines the collection names and schemas. The dev container is still rebuilding, so we wait. Now it's done. I create a new Python file called milvus_setup.py. Since the container was rebuilt, I need to reconnect to MySQL. I'm prompted for the password, enter it, and continue. Now let's focus on the Milvus setup. I copy the code ChatGPT provided and paste it into milvus_setup.py. Hopefully, you're still following along. And if this hands-on tutorial is useful to you, don't forget to like, share, and subscribe. The script connects to the default Milvus instance. This works for us because we didn't change any default settings during installation. Milvus is running on localhost at port 19530. We define two collections, one called posts for post embeddings, and one called users for user profile embeddings. Let's run the script. And boom! The Milvus collections are created successfully. Now we're ready for the next phase, storing real data in our databases. A lot of the logic is already implemented. User login, feedback collection, entity extraction, these parts are working. All we need to do now is redirect them to use the databases instead of in-memory structures. I'll start with authentication. I copy the existing login utility function and ask ChatGPT to update it so it authenticates users against the MySQL database. This also means extending the Gradio interface. If a user doesn't exist, we should offer account creation. I paste the existing interface code to provide context. This introduces new Python dependencies. Since I don't want to rebuild the dev container again right now, I install them directly inside the Jupyter Notebook using exclamation marks. At the same time, I add them to requirements.txt so that the environment is ready the next time I rebuild the container. This is a habit you should really adopt. It will save you a lot of time. Thank me later, but subscribe now. Now let's review the code ChatGPT proposed. It starts by defining a user table using SQL Alchemy ORM. In modern SQL Alchemy 2.0, this means defining a class that inherits from declarative base and using mapped and mapped_column with type annotations. I paste this code into one of the first notebook cells and reorganize the imports. Before going further, I want to verify that the environment variables are correctly loaded. For example, we define db_server in the env file and set it to localhost. I import os and access os.environ with the key db_server. When I print it, I see localhost. Perfect. I'll use these variables to construct the database URL. This is how you build a production-ready application. You don't hard-code sensitive values. You store them in configuration files and reference them by name. We double-check that the table names match. Everything looks good. Now let's update the login function. I paste ChatGPT's proposed implementation and test it. We can refine it later if needed. Next, we extend the Gradio interface to support user registration. Again, I paste the code and integrate it. Now I clear all outputs and run all cells. The kernel seems busy. I restart the kernel, reload the window, and try again. Then I launch all cells. It looks better now. The new login module has been integrated. Let us test it. The Gradio interface is ready. I first try to log in as ktips. It is supposed to return an error. Nope, it works. But why? At this stage, our database is empty, so what I expected was a form popping up and asking the user to first create an account. Let us check what happened in the database. Oops, it looks like the connection instance we created previously is broken. The login is failing. Let us create a new connection. I will keep the same name for my connection. And the same values. Let us test the connection. It fails. I will change the connection name and call it test. And now it works. I will save this connection so I can reuse it later, hopefully. I now have a new SQL file where I can run my SQL commands, but I don't need this for now, so I will close the file without saving. Now back to our code. We want to understand why the user ktips got access to the chatbot, even though the database was supposed to be empty. Let's check if the user's table is still empty. To do that, head over to the left panel, open SQLTools, select your database, then expand tables. From there, open the table we care about, users. Next to the table name, you'll see a search icon. Click it, and that immediately shows you the contents of the table. And, surprise! We already have one user in the database, ktips. That's currently the only user stored. So the real question is, why did this happen? Nothing in our flow explicitly said, insert a user here. Which means it's time to stop and take a closer look at the code ChatGPT suggested earlier. And this is the perfect moment to talk about something important, the danger of what we call vibe coding. Vibe coding is a method of software development where you use natural language, voice or text, to tell an AI what you want to build, whether it's an app, a web page, or a feature. The AI then generates functional code for you, focusing on the desired outcome or a vibe, rather than manual, line-by-line implementation. The danger is that the code works, but you may not fully understand what it actually does. When you let an AI decide the implementation details, especially around databases, authentication, or data storage, you risk introducing hidden bugs, security issues, or unintended behavior. Best practice: use vibe coding to prototype fast, but switch to intentional coding before production. That means reviewing every generated line, understanding how data flows and where it's stored, and being extra strict around persistence, permissions, and security. Vibe coding accelerates creativity. Understanding code protects your system. So let's pause the vibes for a second and audit the code line by line. This is where real engineering starts. The updated login function checks whether the user exists in the database and, if so, verifies the password. If not, this is where the surprise happened. It creates a new user with the username and password we just entered. This is not realistic. Imagine you want to log in and you make a typo in your username. Our system would just create a new user with that wrong username. We have to fix this immediately. Let us refine our prompt in ChatGPT. I type. Don't create the user directly, but ask for confirmation. You can propose a new form asking the user to register first. We first need to implement a new module for user registration. Then update the login function. I go ahead and copy the registration function and add it just before the login function. Then I update the login function. As well as the Gradio frontend. Before testing this, I want to empty the users table in my database. I want to start with an empty dataset. So I create a new SQL file where I run the command, delete from users where username is equal to ktips. Then I execute this on the active connection. After the execution is successful, the users table is empty. I can close the SQL files for now. Now let us test our code. We need to rerun the cells with the registration and login modules, as well as the cell with the frontend. Then I try to log in again as ktips with the corresponding password. And boom! I cannot get access to the chatbot. I need to register a new account. And this is exactly what we want. Let us create the user ktips in our brand new dataset. I enter the password, and we can even confirm the password. Then I click on register. Now I have access to the chatbot again. We can check in the database if the user exists. You see how comfortable this is? I do everything directly in VS Code. I use SQLTools for that. I navigate to the users table and click on the search icon, and here it is, the new ktips user. The auto-increment ID is now at 2. But what is an auto-increment ID in a MySQL database? An auto-increment ID is a numeric primary key that MySQL automatically increases each time a new row is inserted into a table. You don't need to manually provide this value. MySQL assigns the next available number, ensuring that every record has a unique identifier. This is commonly used to reliably reference users or entities, preserve insertion order, and create relationships between tables. Even if a row is deleted, the auto-increment counter usually does not go backward, which is why you may see gaps in IDs. This is completely normal and expected behavior. Now I will test my system again with the question about the weather in Berlin. If you've been with me since the beginning of the series, you already know why our system blocks this question. Next, I ask how to create a post. The system classifies it as relevant and performs entity extraction. We can also test the feedback module by clicking on the thumbs up and thumbs down. If you missed the implementation of this guardrail, please visit the link popping up now. The next step is our conversation history. We can clearly see that the two question-answer pairs our system handled were successfully stored in this variable, along with the corresponding feedback. Let us recap what we did so far. In this second part of day 3, we integrated a proper MySQL-backed authentication system into the application and verified it end-to-end. We connected the running code to the database, inspected the users table directly from VS Code using SQLTools, and validated that user data is now persisted correctly. We introduced a clean separation between user registration and login, updated the Gradio interface accordingly, and confirmed that new users must explicitly create an account before accessing the chatbot. After registering a user, we tested the full flow again, authentication, guardrail filtering, entity extraction, feedback collection, and conversation history tracking. At this point, the database layer and authentication flow are correctly wired into the application and ready to support the next steps. Next, we can write the logic to insert new records into our database. In the users table, we don't only want to store usernames and passwords, we also want to store user interests and the entities we extract from user interactions with the system. To keep users engaged on our platform, we need to understand their current interests and query posts related to those interests from our databases in order to populate their feed. We also want to store user feedback on question-answer pairs, as well as feedback on posts. I will copy the feedback table schema into ChatGPT, along with the function record_feedback, and ask for an update. I think we also need to update the function chat_with_user so that conversation history is stored in the database. First, we update the chat_with_user function. The conversation history now stores all attributes defined in the MySQL feedback table. Next, we update the record_feedback function. This function now stores feedback directly in the MySQL database. For that, we of course need the SQL Alchemy table definition. Here is the feedback class, which I copy and paste into my code. As we can see, several of our tables expect the ID of the currently connected user. This means we need a reliable way to track which user is active while they are interacting with the application. Gradio gives us a simple way to do this using gr_state. We introduce a variable called current_user_id, which stores the user ID for the current session. This value is set during the login process and then reused across the application whenever we need to associate an action with a specific user. To make this work, the login function must return an additional value, the user ID. During login, once the username is found and the password is successfully verified, we return the corresponding user ID and store it in the gr_state. From that point on, the application knows which user is connected. We need to be careful here, because user existence checks and password verification now happen very close together in the function. Instead of blindly adopting the code suggested by ChatGPT, I adapt it slightly to make the control flow explicit and easier to reason about. Next, we connect this logic to the Gradio frontend. When the login button is clicked, Gradio invokes the login function. The inputs to that function are passed using the inputs argument, which references the UI components holding the username and password. Using the outputs argument, we capture the return values of the login function and store them in Gradio components, including the current_user_id state variable. With this setup, every subsequent action in the interface can reliably access the ID of the connected user, allowing us to correctly persist data such as messages, feedback, and future interactions in the database. Let us update this in our code. We still need to copy and paste the current user ID handling into the correct place. Now we can double-check and test. You don't need to understand every single step here, but hopefully you can see what's possible when combining MySQL and Gradio. I must say, I'm positively surprised by Gradio, even though it's not always obvious where certain instructions should live in the code. Let me move this line into the block where we define the Gradio frontend. Or, to be safe, I'll ask ChatGPT. Okay, we can put it after the chat_row column. Or I'll simply put it at the very beginning of the Gradio frontend definition. Now I think we can test it. I clear all outputs and rerun all cells, since we just performed some major surgery. I log in as ktips, and I have access to the chatbot. I immediately ask a relevant question: how to create a post. We get an error. The function user_message takes 2 positional arguments, but 3 were given. We didn't update this function to reflect the new changes, so let's fix that. Here is the problem. We now need to pass the user ID to the chat_with_user function. That means we must update the user_message function to expect this additional variable. Next, I restart the frontend. Log in again. And ask how to create a post. No error this time. The chat_with_user function executes successfully. Now let's test the feedback button. We get another error. The function takes 1 positional argument, but 2 were given. Let me check the database to see if anything was written. Nope, the users table hasn't changed, and the extracted entities were not stored as expected. So we clearly have a couple of things going wrong here. Here is the main issue. We accidentally defined the record_feedback function twice. We need to keep only one version, and we also need to pass the user ID into that function. After fixing these bugs, we are now able to record user feedback. Let's verify that it was actually stored in the database. In the feedback table, we can now clearly see a new entry. It has its own ID, the ID of the user who sent the feedback, a unique question-answer ID, and the feedback value itself. Since we clicked the thumbs up, the value up is stored in the database. Speaking of thumbs up, you can add one to this video as well. So what are you waiting for? We can also check the conversation history. The entire interaction is stored there, but we eventually want to move this into persistent storage. For example, into a Milvus vector store. Let us take a look at the definition of our collections. For now, we have two collections, the users collection and the posts collection. Let us focus on these two for now. We can extend this later with a feedback collection. But I will continue tomorrow. I need to add this to my to-do list. Store the question-answer ID and corresponding content in the vector store. Simulate posts and store them in the MySQL database along with their embeddings in Milvus. Extract user entities from input text. Store those extracted entities in persistent databases. And query them using Similarity search to find posts in Milvus that match user interests. Welcome back. Let's continue with day 3 of this challenge, building a production-ready AI agent application in 7 days. I restarted my working environment, so the first thing I'll do is rerun all the cells of this Jupyter notebook. At this point, most of our implementation already lives here, the backend logic and the frontend powered by Gradio. The first page of our frontend is the login gate. Registered users authenticate here, and once the login is successful, they gain access to the chatbot. For now, I'll log in as K-Tips, since this is still the only user in our database. Once logged in, the user has access to this frontend where they can interact with the chatbot and ask questions. Of course, only system-relevant questions are handled by our application. Now let me clean up the code a bit. I'll remove this function from the front-end definition. This will be useful later, because we want to clearly separate the backend from this Jupyter notebook. This notebook is fine for prototyping, but not for a long-term architecture. Next, we need to extend our front-end. Remember, our application is not only a chatbot. We want something closer to a social media-like platform. So users should have access to a chatbot, but also to a feed of posts. I asked my AI assistant to update the layout into 2 columns. The main content should be on the right side, and on the left side I want to display posts the current user may be interested in. Since we don't have any real posts yet, I asked ChatGPT to hardcode a few of them. These will serve as placeholders until we connect everything to real data. Because our goal is to keep users engaged on the platform, we also want to collect feedback on these posts. Each post should have 2 feedback buttons and 1 comment button. As context for the assistant, I paste the current front-end code. The AI assistant likes the idea and proposes an updated version of the code. As requested, we now have some hard-coded posts, along with the logic to display them. It doesn't look like a big change, so I copy the proposed code and replace my current implementation. Then I relaunch the front end and log in again as ktips. And here we see something interesting. The layout is not exactly what I asked for. Instead of 2 columns, we see the posts, followed by the feedback and comment buttons, which is already good. But the chatbot appears at the bottom, not on the right side as expected. So I refine my prompt. I explicitly ask for the posts to be in their own column on the left, and the chatbot to be in a separate column on the right. I copy and paste the new proposed code and rerun everything. At this point, I suspect something else is happening. The Gradio frontend rendered inside a Jupyter notebook may not have enough horizontal space to properly display a 2-column layout. Since Gradio also generates a public link, I'll open the app in a real web browser and debug it there. This is more realistic anyway, because we will not deploy this application inside a Jupyter notebook. So I paste the link into Firefox and resize the window so you can see everything clearly. Now I log in again as ktips. And boom! This looks much better. We clearly have 2 columns, the post feed on the left and the chatbot on the right. We also see a post feedback status area that shows system responses to user interactions, like feedback on posts. Let me zoom in so you can see the full website. On the feed column, we only have placeholder posts for now. Post 1 is followed by a like button, a dislike button, and a comment button. These indices will be useful later when we record and map user interactions to specific posts. When I zoom out, the layout looks similar to what we saw inside the Jupyter notebook, the feed first, and the chatbot stacked below it. This is probably how Gradio chooses to render the layout when space is limited. We can live with this for now. Let's test the behavior. I start by giving feedback to the chatbot. It deserves a thumbs up. And by the way, so does this video. If you like this content, don't forget to like it, it really helps the channel. Next, I ask a relevant question. How to create a post. The output is exactly what we expect. This is working nicely. If I ask an irrelevant question, like the weather in Berlin, the system blocks it. This is intentional. We are building a social media-like platform where users learn how to be successful content creators, not a general-purpose chatbot. Now back to the code. The gr column instruction is used to create a new column. In our case, the first column is created with a scale of 1, and the second column has a scale of 2. This is why the chatbot column is twice as wide as the feed column. Let me adjust this. I'll change the ratio to something closer to 2/3 for the chatbot. Then I rerun the cell, open the new link in the browser, and zoom out. I log in again as ktips. For me, this layout feels better. What do you think? Do you prefer a larger chatbot or a larger post feed? Many websites now include chatbots. What's your experience with them? Are they actually helpful? And what about their design? Let's discuss this in the comments. This kind of feedback is valuable, especially for front-end designers. For now, I'll keep this design. Next, let's reorganize a bit. I'll move the list of posts out of the front-end section. Remember, these are just placeholders. We'll replace them later with real data. Or even better, let's give users the ability to create their own posts. We can add a Create Post button right here, near the feedback status area. I ask ChatGPT to update the code accordingly. When the user clicks this button, they should be able to create a post. Since I already modified the previously proposed code, I paste my updated version back into the prompt. This way, the assistant always works with the latest state of the code. We can also use the schema of the post's metadata table in MySQL to help the assistant define the function that inserts posts into the database. The user should provide the post content as text. In MySQL, we'll store the raw content without additional processing. Let's see how this looks on the front end. I copy the proposed code, paste it into my IDE, and run it. We immediately hit an error. HTML object has no attribute, update. Let's inspect what's going on. This version of the code renders posts using GR-HTML. I won't spend too much time on this, because the previous approach using Markdown was already working well. So I asked ChatGPT to render the posts as Markdown instead, just like before. I use this updated code, reopen the front end in the browser. And log in as KTips. Now the post feed starts with a Create Post button, followed by the in-memory posts. Let's click the button. A text field appears, followed by a Publish Post button. This already looks very promising. Let me write something and publish it. Of course, it fails. The feature isn't fully implemented yet. To see the exact error, we need to look at the IDE output. The output says, published, so let's inspect the code more closely. We now have a new function called add_post, where the publish logic lives. The first thing I'll do is restructure this code and move this function out of the front-end section. These are habits I've built over time to keep things manageable as projects grow. Right now, the code is still small enough to live inside a Jupyter notebook. But let's see how long that remains true. There's also a variable called post_blocks that needs to be moved. This is a list where each element represents a post, a markdown component for the content, a like button, a dislike button, and a comment button. Now let's look at what happens when we click Publish Post. At the moment, not much happens. The post content is only stored in an in-memory variable. Instead of fixing this partially, I want to do it properly. So I'll extend the code to store posts directly in our MySQL database. Here's my prompt. We already created the MySQL table using the schema I provided, and we also want to add Milvus as a vector store. I paste that context in. Now things get interesting. We will extend the Milvus setup with a collection dedicated to posts. Then we update the add_post function so that each new post is stored both in MySQL and in Milvus. This also means computing embeddings for the post content. So instead of directly updating the frontend with a new post, we first persisted in our data stores. Let's double-check the required parameters. Some fields are mandatory, and if we forget them, the system will fail. Optional fields can stay empty for now. At this point, we are officially interacting with two data stores. In MySQL, we store structured and relational data like posts, users, and metadata. This is perfect for IDs, timestamps, and relationships. In Milvus, we store embeddings of the posts. An embedding is a numerical representation of the meaning of a text, and storing it allows us to perform semantic search instead of simple keyword matching. Later, this will let us retrieve posts that are conceptually similar to a user query, even if they don't share the same words. By computing embeddings once and reusing them, we make the system faster, cheaper, and more scalable, which is exactly what we want for a production-ready AI application. We need to update the schema for posts. Specifically, we have to disable auto-generated IDs in Milvus. Instead of letting Milvus generate its own IDs, we will reuse the IDs generated by MySQL. This gives us a single source of truth for post identifiers and makes cross-database referencing much cleaner and safer. Next, we update the add_post function. This function now follows a clear sequence. First, it stores the post in MySQL. This insert operation returns the post ID generated by MySQL. Once we have that ID, we can safely insert the corresponding embedding into Milvus using the same post ID. This way, both databases stay perfectly aligned. We can already update this logic directly in our code. Of course, to insert posts into MySQL properly, we also need a SQL Alchemy model for the posts table. I add this model to the code. I keep it simple for now and don't update the frontend after each post submission. We'll handle frontend refresh and synchronization later. Let me also reorganize the code a bit. I move all imports to the very beginning of the notebook. This improves readability and avoids subtle issues later when the project grows. Then I update the add_post function accordingly. At this point, the post collection in Milvus is not defined inside the notebook. That's expected. We created the Milvus collections in a separate script called milvus_setup.py. This script defines and creates the collections ahead of time. We now have two options. Either we recreate the Milvus setup logic directly inside the Jupyter notebook, or we interact with already hosted collections using a Milvus client. ChatGPT suggests recreating the setup in the notebook, but I don't want to do that. The application is growing, and we now have multiple components. This is a good moment to start separating concerns. Instead of duplicating setup logic, I import what I need from the Milvus setup file. So I import the posts collection into the notebook. However, we need to rerun the Milvus setup, because we changed the schema by disabling auto IDs. The problem is that a collection with the same name but a different schema already exists. Milvus doesn't allow redefining a collection with the same name. I'm not very familiar with Milvus yet, so I asked ChatGPT for guidance. The updated solution first checks whether a collection with the same name already exists. If it does, we delete it and then recreate it with the new schema. Since we're still in the setup phase, this is totally fine. Now the new collection is created with the schema we want. Let's test the code in the notebook. Something strange happens here. I only import the post collection object, but it looks like the entire Milvus setup script is executed again. That's not ideal and definitely not what we want in a production setup. Before fixing this, I want to point out something important. We use the same embedder as in the previous videos of this series to compute embeddings for posts. The embedder is already defined at the top of the notebook, so we can reuse it directly here. Now, back to this Milvus issue. Instead of importing the collection object from the setup script, I decide to use the Milvus client directly via PyMilvus. This gives us more control and avoids unexpected side effects. I create a Milvus client pointing to our Milvus instance, for example localhost on port 19530. I also set the authentication token to root Milvus. With this client, we can interact with existing Milvus collections. To insert data, we use Milvus_client.insert. We need to be careful here, because this method expects the collection name and a list of values formatted exactly according to the schema. Let's run the script. We hit an error again, but this time it comes from MySQL. The logs say the posts table already exists. SQL Alchemy suggests using extend_existing equals true to redefine options or columns on an existing table. This usually indicates column mismatches between the model and the actual table. At this point, things may look a bit messy, and that's okay. You don't need to understand every line of code here. What matters is seeing what's possible with these tools and how real-world integration issues look like. For now, I remove the SQL Alchemy model to unblock myself. We'll come back to this and clean it up properly later. Now I test the application again. I open the front-end link in the browser and log in as ktips. I try to create a post. Instead of writing one from scratch, I take a topic from our guardrail and ask ChatGPT to generate a sample post. I copy it into the application and click Publish. We get another error. Let's fix it. The issue is that we didn't provide all required fields when inserting into the posts table. That means we either need to provide all fields or update the table definition so some fields can be optional. In other words, we need to properly fix the issue we saw earlier and update the table definition. We can't provide all fields yet. The solution is to set extend_existing equals true using the table_args attribute. I add this. And I also ask ChatGPT to confirm. Yes, this is the right approach. Let's continue. I rerun the relevant cells and restart the front end. Another error appears. The add_post function expects the ID of the current user, but we didn't correctly pass it from the front end. Let's fix that and try again. I open the new link, log in as ktips, and publish the post. We hit yet another error. This time, the add_post function doesn't return enough outputs. For now, I simplify things. I modify the function and the button click handler so it returns only one output. We don't need to refresh the feed yet. Let's test again. I open the front end in a new browser tab. Log in as ktips and publish a post. The error is different now. The front end receives a successful response, which we can see in the status field, but the back-end logic still fails. The problem now comes from Milvus. We didn't call the insert function with the correct structure. Before fixing that, let's verify something important. Did the MySQL insertion succeed? I go to the left panel, open the MySQL tools, select the posts table, and click the search icon. And boom! We have 2 entries. This means we successfully connected our application to MySQL. We have a post ID, the ID of the user who created the post, and the text content of the post. Now let's fix the Milvus part. It looks like the values passed under the key data need to be provided as a dictionary. I update this and try again. Same procedure. Open the application in the browser, log in as ktips, and publish a post. Another error appears, but this time it's much more specific. The post ID is expected to be an int 64, but I passed a list. This should be an easy fix. I copy the error message into ChatGPT to get the full context. It's clear now that we formatted several values incorrectly. We need to fix all of them. For the embeddings, I add a quick debugging step and print their type. They should be a list. Let's rerun everything and test again. This is a good time to restart the kernel as well. I rerun all the cells. Then I copy the generated link and open it in a new browser. I log in as ktips. The login is successful, so I can create a post. I click on Publish Post. We immediately get an error, attempt to insert an unexpected field called content into a collection without dynamic fields enabled. This means the Milvus collection schema does not define a field named content, and dynamic fields are disabled, so Milvus refuses any extra attributes that were not explicitly declared at creation time. In our case, this is actually expected behavior. We don't need to store the raw post content in Milvus because Milvus is only meant for vector data. We already designed the system so that the full text lives in MySQL. Milvus should only store embeddings and references. A quick look at the Milvus schema confirms this design choice. So the fix is straightforward. We remove the content field from the data we insert into the vector store and keep only the embedding and the post identifier. This also helps us avoid database redundancy. Redundancy means storing the same information in multiple places, which wastes storage, increases the risk of inconsistencies, and makes maintenance harder. By keeping the raw post text only in MySQL and storing embeddings in Milvus, we maintain a clean separation of concerns and a single source of truth. Now we rerun this code cell and restart the frontend. I open the new link in a fresh tab and log in again as ktips. Next, I create a post and publish it. And boom! The post is published. Congratulations! You just successfully inserted your first embeddings into a vector store. Now that we have real posts in the database, we can remove the hard-coded posts. Instead, we will replace them with a function that queries posts directly from our MySQL database. We will also update the feed to display the name of the user who created each post, along with the creation timestamp. For the design, we can render this metadata using a smaller font size so it stays informative but unobtrusive. I copy and paste the new function responsible for fetching posts from the database into the Jupyter notebook. This function relies on the user SQL Alchemy class, which I believe we already defined earlier. Yes, we do have it, but it looks like there is a small typo. I fixed that. Much better. Next, we update the feed rendering logic in Gradio. We replace the existing code block with the new implementation. We also introduce a new function called refresh_feed. This function queries the database and builds a list of up to 10 recent posts. There is also a refresh feed button that triggers this function. I transfer all of this into the code. But not here, this is the wrong place. We need to insert it after the function that fetches posts from the database. Now we test it. It fails. We forgot to re-execute the cell where the get_posts_from_db function is defined. Let's quickly run it. Then we rerun the front end. You know the routine by now. Open the front end in a new browser window and log in as ktips. Excellent. This looks really good. We now see posts coming directly from the database, each one showing its author and creation time. Let me zoom in so you can see it clearly. While we were fixing Milvus, we repeatedly inserted the same post into MySQL, which is why the same content appears multiple times. That's perfectly fine for now. One thing I don't like is that the like and dislike buttons are followed by the post index number. Let's remove that. Actually, let's go one step further and remove the text entirely, keeping only the icons. Everyone understands what they mean. I also remove the index from the comment button. Let's rerun everything and test again. I think it already looks better, although I'm still not fully satisfied. The buttons take more space than they should. We could reduce their size and maybe align them vertically. Still, let's give this app a thumbs up. It's doing pretty well. We are building a complete front-end using Gradio. What do you think about this approach? Do you also build small projects just for fun, using tools you've never worked with before? For me, this is the best way to learn new technologies and compare them with tools I already know. I'm curious how you do it. Do you rely on tutorials and videos, or do you also prefer hands-on projects? Personally, I like learning without deadlines, just experimenting and exploring. And speaking of thumbs up, don't forget to like this video. Back to the code. I also think we don't need to display the post number at all. Showing just the title is enough. While we're at it, we can clean things up and move function definitions out of the front-end section. Now let's do a quick recap. For day 3, we successfully set up a MySQL database and a Milvus vector store. We implemented the logic to insert new entries into both databases. At this point, you clearly see the separation of responsibilities. Structured relational data like users, posts, and metadata live in MySQL, while large text is transformed into numerical vectors and stored in Milvus. We also implemented functions to query data from MySQL. We could stop here for today, but let's extend this just a bit more. I ask my AI assistant to implement a function similar to our data extraction logic. We will use this function to track users based on the content of their posts. Every time a user submits a post, we extract signals about what they are interested in. Later, we will use this information to personalize the experience and keep users engaged. All of this will be stored persistently in MySQL. I refresh the context for the coding assistant and paste the fields we want to extract. This function performs an LLM call to extract structured information from the post content. I copy it into the code. Next, we update the add_post function and invoke this new extraction step inside it. Now we don't just store the raw post, we also store additional information the user never explicitly provided, such as a generated title. The user only writes the content, and the system generates a meaningful title automatically. This helps us avoid clickbait. Clickbait refers to exaggerated or misleading titles designed purely to attract clicks without delivering real value, something we want to avoid in our platform. We also query this generated title so each post in the feed can start with it, making the feed clearer and more readable. Let's rerun everything. We hit an error. The SQL query does not return the title. We forgot to include it in the query, so let's fix that quickly. We try again. It still fails. The error says the posts object has no attribute called title. We could add this attribute to the SQL Alchemy model, but for now we can simplify and use the topic field instead. So we replace title with topic. We test again in a new browser tab and log in. That's strange. The topic value is none. This probably means the entity extraction function was not triggered when the post was created. Let's create a new post to test this properly. I copy an existing post and publish it again. Publishing now takes a bit longer because we added an LLM call to extract entities from the content. Next, we refresh the post feed. Same issue. The topic is still empty. We need to inspect the code more closely. I add a debugging step to log which entities are actually being extracted. I restart the app and create another post. Now I check the logs. It turns out the language model was not able to extract a topic from the provided text. This is a real problem, and we will need to fix it with better prompt engineering. I want to simplify my testing workflow a bit. Instead of using the front end, I will debug this function directly in the notebook. This will help us save some time. So let us create a new code cell where we invoke the function extract_post_entities. As this function only expects a text input, I will paste the content of our post directly here. We need to adapt the text formatting so it fits Python syntax. I remove unnecessary whitespace and slightly restructure the text. Then I run the cell. We get an error, the function is not defined. Since I restarted my working environment, we need to rerun the cell containing this function. I will also rerun all dependent cells. Now, next try with the function. The error is clear, the code failed to parse the JSON returned by the LLM. We can see in the raw output that the entities were actually extracted correctly, at least the ones present in the text. But the problem we have here is a well-known one. The LLM added extra formatting instructions around the JSON. So we ended up with something that looks like JSON, but is not valid JSON from Python's perspective. We already encountered this exact behavior in the implementation of day 2. Do you remember? Feel free to check the link popping up now to see how we debugged and fixed this issue back then. Here, I will not spend too much time on it and will directly reuse the prompt instruction from the extract_data function. I paste it here. The LLM should now return only a valid JSON object, without any extra explanation or formatting. Then I rerun the function and test it again. And boom! We now have a valid Python dictionary ready to be used in the subsequent code. Now let us see how this function behaves inside our application. We can remove this temporary debugging print of the extracted entities. I will rerun all cells. In the meantime, we can check what is happening in our database. I go to the left panel, select the SQLTools, navigate to the Posts table, and click on the search icon. Surprise! We have a couple of posts here, but none of them have useful extracted entities yet. We will fix this now. But before that, I want to add a small pre-processing step when invoking the function. I will remove extra whitespace from the post content to avoid potential parsing errors later. Next, we restart the app and open the Gradio generated link in a new browser tab. Then I log in as KTips. Without losing time, I create a new post. Then I publish it. Next, I refresh the post feed. We still don't see the topic displayed as the title of the post. So it still does not work as expected. We need to check the logs. We see an attribute error here. Module bcrypt has no attribute about. This error does not seem to come from the post insertion logic, but rather from the refresh action. Let us check the database anyway. In MySQL, we have confirmation. The entities were successfully extracted from the user-submitted post and stored in our database. We can see the topic extracted from our sample post. The LLM called it customizing social media feed, which I think is appropriate. Let us refresh the feed again. No change. So the action behind this refresh button is not working as expected. The exact error must be in the notebook logs. Let us look closely at the implementation of the function that retrieves posts from the database. Wait, we have a limit set to 10. So the function may only be querying the first 10 posts from our MySQL database. Let us increase this to 20 and see what happens. Since we already have more than 10 posts stored, this is safer. I rerun the code and refresh the post feed. And voila! We now see the title appearing, followed by the post content. But we can improve the design. The title should be on its own line. I fix this immediately. Or, even better, I ask ChatGPT for a cleaner layout. I then copy its proposal into my code, both in the function that initializes the feed at login and in the function triggered by the refresh button. Then I rerun everything. Same story. I open the link in a new tab and log in as K-Tips. And boom! You see it? Let me zoom in. The post starts with the extracted topic, which we now use as the title, and ends with the creator name and the creation time. We are getting closer to our goal of building a real social media-like application. This design is fine for me for now. I will adopt it. Next, we could also update the function that extracts entities from user interactions with the chatbot, so it behaves similarly to the one extracting information from user posts. Does this make sense? Users interact with our application through two main channels, when creating posts and when asking questions to the chatbot. In both cases, we have the opportunity to learn about user interests. For now, the extraction function does not capture that much information, so I will ask for refinement. Some entities, like user age or location, should still be manually provided by the user. Let us refresh the context of our coding assistant by providing the function definition. I am a bit skeptical about the proposed solution, so let us double-check the schema. I give it a try and update the function. Copy. Paste. And execute. To test this, I will copy part of a post and paste it into the chatbot. This is our message. It takes a bit of time to extract the entities, which is fine, we are calling an LLM after all. Then it failed to parse JSON. The raw output is empty. We need to check the logs. I will debug this directly in the notebook again to avoid the front-end login gate. I create a new cell and invoke the extract_data function with the same input text. Same output, the LLM return nothing. The prompt looks fine. But to be safe, I add an instruction. If you are not able to extract any entity, return none. I rerun and test the function. No change. So I undo this modification. Let us try with a shorter input. My name is K-Tips and I am 18 years old. It works. The age and sentiment are successfully extracted. The topic and time reference are also reasonable. Now let us try a shorter input in the front end as well. I ask how to create a post. The system fails to parse the JSON again. In fact, the JSON is incomplete. It looks like the large language model did not finish its answer. Here is why. The max token limit is set to 400, which may seem enough at first glance. The final JSON output alone would likely stay below that limit. But GPT-OSS-20B is a reasoning model. It generates tokens not only for the final output, but also for its internal reasoning. Those tokens are counted as well. So the 400 token limit applies to the sum of internal reasoning tokens and the final output, not just the visible response. Let us increase the limit to 500 and ask again how to create a post. Now we get a complete response. The entities are correctly extracted. We can now move to the next step. We update the chatbot entry point. We check for extracted entities and update the corresponding values in the MySQL database. I think I will put my database references directly into the context of the assistant. This avoids modifying too much of the proposed solution. I only copy the code handling the case where the label is relevant. The session handling is not well defined yet, so let us fix that. The code first checks whether the user exists in our database and then inserts the extracted entities. If it works as expected, we should see these entities updated for user K-Tips. So let us ask again. How to create a post. Looks fine. Entity extraction works. Now let us check the database. No updates. The extracted entities were not stored. Let us debug this. I am not sure what is going wrong. Maybe we need to rerun all cells. I restart the app in a new browser. Log in as ktips. And type, my name is ktips, how to create a post. The extraction succeeds. But where are the entities? The database is unchanged. I asked ChatGPT to insert logic similar to what we implemented in the add_post function. We try this proposal. The code complains about an update error. Let us fix it by importing the correct SQLAlchemy method. Then we retry. I send the same message again and check the database. Still no insertion. Let us return the error in the system reply for debugging. I send the same user message again. Here we go. The error is, unconsumed column names, preferred topics, language, age. These fields were not present in the database schema, but the code tried to insert them. I asked my assistant to fix this. We need to update our SQLAlchemy user model to include these fields. I copy the updated model and replace the old one. I think we can now remove the extra debugging steps. Then rerun and test everything again. No SQL error in the system reply. This already looks very good. Let us check the database. Fantastic. The age is now set to 0, the detected language is English, and the preferred topics include social media and posting. This is exactly what we expected. Some keys are still missing, and I am not entirely sure whether the topic should belong in the users table. We already store preferred topics, so let us keep it like this for now and recap. Our goal is to create an application with a chatbot and a post feed where users can learn how to be successful as content creators on social media. Today, we successfully set up a MySQL server and created 3 tables, one for users, one for raw post content, and one for user feedback. We also set up a Milvus vector store to store embeddings of user posts. Each time a registered user submits text to our application, we extract information about potential interests and store it in MySQL. We will later use this to keep users engaged for as long as possible. For now, we can query posts from the database. But one critical thing is still missing. We blindly display the first 20 posts, regardless of whether they match the interests of the currently logged-in user. This will be the focus of our next implementation. Based on extracted user information, we will perform a similarity search on the Milvus post collection and only display posts that are relevant to the user's interests. Let us verify the feedback function. I give a thumbs up to the chatbot. And in the feedback table in MySQL, we see a new record inserted. But I don't like how we currently store the question answer ID. This could backfire later. We generate a unique UUID for each question answer pair, but users can also send feedback on posts displayed in their feed. In that case, we need a way to store post IDs. How do we do that? For chatbot feedback, we assume the feedback refers to the last question answer pair. But this assumption does not hold for post feedback. I copy the current frontend code and ask ChatGPT for help with this design. I ask it to update the code to record user feedback for each post in the feed. I also add the schema of the feedback table to the context. It proposes adding a new table for post feedback. Let us adopt this idea for now. I first add the SQL Alchemy model in the notebook. Then I add the record_feedback function. But wait. We already have a function called record_feedback for chatbot feedback. So I rename the new one to record_post_feedback. This is a bit awkward. Also, the frontend is not ready for this yet. The like, dislike, and comment buttons are not associated with any post identifier. So when a user clicks a button, we have no way to know which post it refers to. I also don't want to create a separate feedback table. We could reuse the same table and adapt it. Let us see what the assistant suggests. We provide the feedback table schema and add a prefix, like post, to indicate post-related feedback. I will start by updating the button click handlers. There is not much that can go wrong here. Any database experts here? What do you think about combining multiple pieces of information into a single string column in MySQL? Let me know in the comments. We will revisit this design later. For now, let us implement post identifiers in the frontend. Let us test it. I run the code. Restart the frontend. Log in as ktips. And give feedback on a post. Let us check the logs. It looks good. The feedback actions were recorded. Now the question is, were they stored in the database? Let us check immediately. Yes, we see new entries. But the question answer ID is not well formatted. The post ID is correct, but the current user ID was not passed. Let us fix this in the code. The issue comes from string formatting. I ask ChatGPT for a fix. I replace the button click actions. Next try. We immediately hit another error. Int object has no attribute _ID. We need to wrap a partial lambda and directly pass the post ID as a parameter. Let us test again. Perfect. It works as expected. We now record every interaction the current user has with our application. The semantics are still missing, but we already see the pipeline taking shape. On day 4, we will use Pydantic to validate model outputs. For example, in extract_data, we currently rely on JSON.loads to check whether the LLM returned valid JSON. With Pydantic, we can define strict data models with explicit fields, types, optional values, defaults, and validation rules. This allows us to validate not only structure, but also meaning. If something is missing or malformed, Pydantic raises clear errors, making the system more robust and production-ready. In the second part of day 4, we will use Pydantic to validate extracted data before storing it. Our database currently contains a lot of experimental data, and we will clean it up once the schema is stable. We will also wrap our custom Python functions into callable tools. This is where the magic happens. We will implement an agent that decides which tool to use. Now it is 11:15 p.m., and I think I will stop for today. We are still implementing day 3, but I will continue tomorrow. It is another day, and I continue with the implementation of day 3 of our 7-day challenge. So far, we have a MySQL database set up and a Milvus vector store ready and already in use in our application. We can store raw user profiles and posts in the MySQL database, as well as post embeddings in the Milvus vector store. Once a user registers and/or logs in, they gain access to our website, where we display a post feed, typically on the left side, and a chatbot, typically on the right side. Our frontend is powered by Gradio, and we have already seen that depending on the available space on the page where the frontend is rendered, Gradio may automatically restructure the layout and reposition different components. For day 3, there is one important feature missing in our application. The posts displayed to the currently logged-in user are random. At the moment, we simply select the first 20 posts from our database and show them to the user, regardless of whether the user is interested in them or not. However, our goal is to build an application where users stay as long as possible. To achieve this, we need to understand what the current user's interests are and use that information to provide content that is relevant to them. We collect the current user's interests during their interactions with our platform. We have two main sources for this. The first one is the post feed, where the user has the possibility to create and submit posts, as well as give feedback and comments on existing posts. The second one is the chatbot. The user can ask questions to our backend, and a large language model generates answers. From the user's messages, we extract information to enrich the user profile stored in our database. In addition, the current user always has the possibility to provide feedback on the last question-answer pair. Both the interaction and the feedback are stored in our database. Next, we want to implement logic to use this user information to personalize the post feed. Since I just restarted my working environment, I am going to relaunch the application and execute all the cells of my notebook. Now I log in directly from the notebook. Given that the only user we have so far is KTips, I log in as KTips. Then I create a new post, just to check that everything is working correctly. I click on Publish Post. The post is published, but what I see is not very satisfying. When the user submits a post, the content of the post is still present in the input field. This is not the expected behavior. What I do next is copy the front-end code and ask ChatGPT to update it. What I want is the following: when the user submits a post. When they create a post, the content of the input field should be completely cleared. The post content should not remain visible in the input field. The function we are using is add_post. After this function has been invoked, we need to reset the text box, hide the post submission form, and display the Create Post button again. I provide my code as context to my assistant, and it proposes a solution. My assistant suggests new helper functions. The first one is show_post_form. This function returns two Gradio components, resets them, and makes them visible. The second function is handle_submit_post. I copy these two functions and integrate them into my notebook. Both functions return Gradio components and reset some of them. I can see that the second function resets the text box and makes the Create Post button visible again. We also need to update the actions triggered when clicking the Create Post and Submit Post buttons. When we click Create Post, the invoked function returns an empty text box. When we click Submit Post, the handle_submit_post function is invoked. It takes the submitted text and the username as parameters, and then returns the Create Post button again. I copy this code and paste it into my notebook. I place it in the section where the two button actions are defined. Then I re-execute the code. I open the link generated by Gradio in my browser. As usual, I log in as KTips. I test everything and click on Create Post. And nothing happens. When I click on Create Post, it no longer reacts. Something is clearly wrong in the code. I go back to my notebook to see what is happening with the new functions. At first glance, everything looks normal. I restart the application and try again. I log in directly from the notebook as KTips. Once again, when I click the button, nothing happens. The good news is that we now see an error in the notebook. Value error. The function show_post_form did not return enough outputs. I scroll up and inspect what the function actually returns. The function returns 2 Gradio objects. Now we need to compare this with what the button action expects. Here is the problem: the function was defined twice. In fact, we already had a function with the same name, and ChatGPT updated it. I did not pay enough attention to that. I delete the second version of the function. I double-check and re-execute the cell containing the final version of the function that I want to keep. Then I restart the application. I log in directly from the notebook. Now when I click Create Post, things look much better. We see the form again, with the input field where we can type our post. I copy one of the existing posts and submit it. Then I click Publish Post. Now everything works properly. The input field disappears, and the Create Post button is visible again. I click Create Post once more to see what happens. This is still not correct. The post submission form appears again, but it contains the content of the last post I submitted. I go back to my notebook and inspect the functions again. At first glance, everything looks fine. The text box is supposed to be reset. Maybe the function was defined twice again? No, that does not seem to be the case. However, there is another issue. The function returns 2 Gradio elements, but we are actually accessing 3. I look at the logs and then directly ask my assistant. I type. The text box still has the old content when I click Recreate. It proposes new updates for both functions. The key point is that the first function also needs to explicitly clear the text box, just like the second one. I copy the updated code for the first function and integrate it. Then I do the same for the second function. Yes, I also update the button actions accordingly. I paste everything into my notebook and re-execute the 2 cells. I copy the Gradio link and reopen the application in my browser. I log in as KTips. I create a new post and click Publish Post. Then I click Create Post again. Now everything behaves as expected. The input field is reset, and we can create new posts without any issue. At this point, we are good, and we can move on to the next step. I ask my assistant for help to refresh the post feed immediately after a post submission. We postponed this earlier, and now I want to handle it. The assistant proposes an update to the handle_submit_post function. I adopt it and add the new line to my code. I also update what the function returns. Next, I update the action executed when clicking the Submit button. After the user submits their post, the feed refresh function is invoked again. Until now, this feed refresh function was only used during application initialization. I integrate this new functionality and clean up the code slightly. I restart the application in my web browser. As usual, I log in as ktips. There is a small typo here. Once inside the application, I create a new post. I simply type, new post creation. And boom, the post is immediately displayed in the feed. The creation time is 18:29. I am in GMT+2, so it is clearly the post I just created, and it appears directly in the feed. Next, I verify the database again. I navigate to the left panel and select SQLTools, then connect to the database. What interests me most here is the schema of the tables. I copy the full table definitions and ask my assistant for help. I ask, I want to extend the feedback table to also store comments. Until now, this functionality was not implemented. Users cannot leave comments on posts displayed in the feed, and we want to fix this. It might make sense to store comments in the Milvus vector store, so I ask my assistant for its opinion. I also copy the entire Milvus setup file and provide it as context. The assistant proposes 3 options. The first option is to extend the existing feedback table so that comments are directly associated with likes and dislikes. This simplifies SQL queries, for example when selecting feedback by post ID, but it is not ideal for semantic search. The second option is to create a separate MySQL table for comments. This could be useful if we later want to store different types of comments, not only comments on posts. The third option is to store comment embeddings in a Milvus collection. This third option seems the most logical to me. More precisely, we can store the raw comment text in the MySQL feedback table and store the embeddings of those comments in a Milvus collection for semantic search. I copy the SQL code to add a comment column to the feedback table. I select the database, click on the +SQL icon, paste the query, and execute it. There is no error, so the table should be updated. I verify the feedback table and confirm that the new column exists. For existing rows, the comment column is empty, which is expected. The column is initialized, but only future inserts will contain values. I close the SQL file without saving. Then I update the table definition in my documentation to include the comment column. Next, I create the new collection in Milvus. I copy the code proposed by my assistant, slightly rearrange it, and execute it. The collection is created successfully. The existing post-related collections were deleted. This is not a major issue for now, but it is something we need to be careful about going forward. The application is becoming more complex, and deleting collections or databases is becoming more delicate. Now we need to wire the comment button in the Gradio frontend. I want to simulate a pop-up window. When the user clicks the comment button, a window with an input box, a submit button, and a cancel button should appear. I want to reuse the existing record_feedback function and extend it so it can now store comments in the MySQL database and embeddings in the Milvus vector store. I provide the current definition of the function and the Gradio interface code to my assistant. The integration will happen in several steps. The first step is updating the record_feedback function. We need to add the comment field and include it in the data stored in the database. Since this function is already used for like and dislike actions, we need to handle a special case. Depending on how the function is triggered, it either records a like/dislike or inserts a new comment. For comments, we store the user ID, the post ID, the comment embedding in Milvus, and the creation timestamp. The second step is updating the frontend. We add a new window that appears when the comment button is clicked. Gradio does not support real pop-ups, but we can simulate them by toggling component visibility. The third step is connecting the comment button to the comment submission form. The fourth step is defining the actions triggered by the submit and cancel buttons. At this point, I am not fully satisfied with the solution, so I ask my assistant to explicitly use the existing Milvus client. The embedder was already defined on day 1, in the very first cell of the notebook. I update the assistant context with the relevant code and function definitions. It asks to create the comment column, which we already did. It then asks to create a comment collection in Milvus, which we also already did, so I skip this step. Now we focus on updating the record_feedback function. I check the actual field names of the comment collection in Milvus, since they do not exactly match what ChatGPT proposed. I update the function accordingly. Then I get an error saying that the Milvus_client object is not defined. In reality, it already exists. I simply need to make sure the initialization cell is executed. I re-execute the cell so the changes take effect. Next, I move on to the interface. The assistant only provides a partial interface, so I ask for the full Gradio code that includes the comment button logic. At this point, it starts generating the entire application, which is not what we want. I clarify the request and provide my current interface code as context. The assistant redefines record_feedback again, which is fine. I copy only the newly required helper functions and integrate them into my code. I then copy the proposed frontend code into my notebook and execute it. We get an error, comment_modal is defined. I send this error back to my assistant. The issue is that some variables are referenced before being defined, so we need to adjust the order of definitions. I apply the proposed fix and re-execute the code. Now we get another error. Int object has no attribute ID. This is a known issue related to partial lambdas. To save time, I copy the error and the relevant code and send them to my assistant. It suggests modifying the open_comment_modal function. This is not the core issue, but I try it anyway. The error persists. I try the next proposal. And this time it works. I copy the Gradio link, open the application in my browser. And log in as ktips. I click on the comment button below a post. At the top of the page, a new window appears with the title, Add Comment. This is not exactly what I wanted, but I test it anyway. I submit a comment. There is no visible error. I check the logs, nothing appears. I then check the database to see if the comment was saved. No, the comment was not stored. I try submitting another comment. Now we finally see the error. The comment column is not defined in the SQL Alchemy model. I locate the SQL Alchemy model for the feedback table and ask my assistant to add the new column. Meanwhile, the assistant finishes generating the previous response about the pop-up. I copy the Gradio-related code and replace it in my interface. I also update the button action. I fix the SQL Alchemy model and re-execute everything. We now get another error. Gradio has no attribute called modal. At this point, it is clear that my assistant is getting confused. Earlier, it correctly explained that Gradio does not support real modals and that we must rely on visibility toggling, but now it contradicts itself. So what I'm going to do is forward this error to my assistant. The answer brings us back to the first solution we had, which is to play with the visibility of the pop-up component. However, I also know that there is an existing solution in Gradio via an additional library called Gradio_modal. So I'm going to help a bit here and ask my assistant to base the solution on that library. What is very likely happening here is a stale data problem. As you know, large language models are trained on massive amounts of data, mostly available on the internet at the time of training. If, for example, this new library did not exist yet when the model was trained, then the model won't know much about it. In those cases, models or applications like ChatGPT often rely on web search and what we call RAG, or Retrieval Augmented Generation. RAG systems enrich the model's knowledge by injecting additional, up-to-date context at inference time, so the model can produce more accurate answers based not only on its training data but also on external information. My assistant now suggests installing this library using Python. I quickly copy the instruction and execute it directly in my Jupyter notebook. Since my working environment is a VS Code dev container, I also add this dependency to my requirements.txt file. This is more of a personal reflex. As I mentioned earlier, I like to prototype in Jupyter notebooks. I'm a big fan of Docker containers, which is why I prefer developing inside dev containers. The downside is that rebuilding containers often takes time, especially as the application grows. So in this case, instead of rebuilding the container immediately, I install the new dependency directly inside the running container. I only rebuild the container when it's absolutely necessary. But every time I install a new dependency, I still make sure to add it to my dependency file. For those of you who also work with dev containers, I'd be curious to know how you handle this. Let me know in the comments, I'd love to learn from you. And don't forget to subscribe to the channel for more tips like this. Once the library is installed, I try to use the code snippet. I start by copying the import statement and, as always, I add it to the very first cell of my Jupyter notebook. Then I copy the code that needs to be added to my Gradio interface and slightly adapt it. Next, we need to update the corresponding button. I follow the same process. I copy the code proposed by my assistant, add it to my notebook, and adjust it. Now we can also update the function that displays the pop-up window. I execute everything, and we get an error. Type error, modal __init__, got an unexpected keyword argument title. We're going to fix that. I think the language model doesn't really know this library very well. I copy the error and send it back to my assistant. It suggests replacing the title argument with a markdown component instead. I copy that change, update my notebook, and re-execute. For now, no errors. I quickly copy the Gradio link, reopen the application in my browser, log in as KTips, and click on the comment button under a post. And voila! We now have a very nice pop-up window with the title, add a comment, a text input field, and submit and cancel buttons. That's exactly what we wanted. We can also see the status of each request after execution. I test the pop-up by typing a comment and clicking submit. The code executes, the pop-up disappears, and there are no visible errors. Let's check the database. The database is still open in my browser. I select the feedback table and click on the search icon. Unfortunately, there's no new insertion. Let's check the logs. Nothing obvious. No new comment in the database. Something strange is going on, but we'll find the issue. I add another comment. When I click again on Add a Comment, the pop-up appears, and now I can see the status of the previous request. There's the error: the comment column is not defined in our SQL Alchemy model. Let's fix that immediately. I either go directly into my code or ask my assistant to fix it. It proposes a new feedback class. But we've already executed the command that adds the comment column to the database. It suggests recreating the column or dropping and recreating the table, but before doing that, I double-check my SQL Alchemy model. When I recheck, I notice that the cell defining the feedback model had already thrown an error earlier that we missed. This is a familiar error, since the table already exists. To modify its definition, we need to add extend_existing equals true. I copy this error into my assistant, take the additional line it proposes, and add it to my notebook. I re-execute. Copy the Gradio link. Reopen the application. Log in as K-Tips. And try again. I submit a comment, test. Then I click Add a Comment again to inspect the previous request status. This isn't final behavior. We'll improve error reporting later. Now we get a new error: invalid post_ID. The table expects an integer, but apparently nothing was provided. I copy this error again and send it to my assistant. In the meantime, I check the database. Good news, the comment was saved correctly in MySQL. So the error likely comes from the Milvus collection. Let's recheck the record_feedback function, or the function that sends the comment. We need to make sure that we're passing the post_ID correctly to the function that inserts into Milvus. At first glance, the code looks fine, but we need to inspect it carefully. At this point, I can't immediately spot the issue, so I ask my assistant again. I realize that the function that opens the comment pop-up doesn't properly format the post ID. I quickly fix that and update the button action. Now let's get back to the Milvus insertion. According to the documentation, we need to insert objects as Python dictionaries where keys are column names and values are lists. I'm not entirely convinced this is correct in our case, because only the embeddings are lists, everything else is scalar. I suspect the problem might be in the submit_comment function. I ask ChatGPT, but the proposed solution doesn't make sense to me, so I don't adopt it. I clarify that I believe the issue lies in how submit_comment invokes record_feedback. The assistant insists that Milvus requires lists. To test another hypothesis, we try capturing the post_ID using a Gradio state, because it seems the value being sent is empty. We re-execute, but we're back to the previous error. At this point, things are getting messy. I decide to copy the entire interface and ask my assistant to reorganize it. This should save some time. The proposed solution still doesn't fully convince me, so I fix the issue myself. We need to redefine some functions, especially those using partial. We've already encountered this error before. My assistant gets confused again, so I correct it manually and re-execute. No errors for now. I open the app in a new browser window, log in, and submit a comment. We get another error. The add a comment modal now shows multiple text fields, one per post in the feed. That's not what we want. We only need one text field. I check the logs and see a type error. Submit_comment. Takes 3 positional arguments but 4 were given. Looking at the function definition, it actually expects 4 arguments, and 4 were provided, so the error doesn't make sense. I ask ChatGPT again, and then I realize the real issue. I forgot to re-execute the cell after modifying the function. I execute the cell. Restart the app, open it again, log in, and submit a comment. No error. When I click add a comment again, the request status shows success. Perfect. Now we can fix the remaining UI bug. We should not display multiple text inputs in the pop-up. Only one text field, like at the beginning. I inspect the code responsible for creating the pop-up. It turns out this code is inside a for loop that iterates over posts. I move that part outside the loop. Finally, we make sure that current_post_ID is defined in the right place. This variable should store only the ID of the post selected by the user. Remember, each post has its own add comment button, and we attach the corresponding post ID to that button. We need this to correctly associate comments with posts in the database. Next, I restart my application. I copy the generated link and open the app in my web browser. I log in as K-Tips and try to submit a comment. Then I click again on Submit a Comment, and this time we get an error coming from the Milvus database. Before fixing this error, I first check my MySQL database. And indeed, we can see that the new comment has been correctly inserted. The identifier is properly formatted. So the MySQL side looks good. Now let's go back and review the definition of the record_feedback function. We also need to recheck the column types of the comment collection in our Milvus_setup file. I copy the error message and ask my assistant how to fix it. You can see that it keeps insisting on passing all attribute values as lists, as arrays. At first, I don't really understand why. I don't have much experience with Milvus yet, and intuitively it doesn't make sense to pass every value as an array. So I decide to do some research. I go directly to the official Milvus documentation to understand how data should be formatted when inserting into a collection. And it turns out that, indeed, Milvus expects values to be passed as lists, even if you're inserting a single record. Since we already inserted data into another Milvus collection earlier, I try to reuse the same pattern. To help with debugging, I decide to explicitly print the post_ID inside the error message. I inject the post ID directly into the log output. Then I go back to the frontend and submit a comment. No change. I realize I probably need to re-execute my code. I do that, submit another comment, and when I click again on the comment button, I can see that the feedback was recorded, but the content is empty. So what's going on? I submit yet another comment with the content test, and once again I get a type error. On top of that, the post_ID we're trying to display is not consistently formatted. Sometimes it's none, sometimes it's missing altogether. Clearly, something is still wrong with how we handle the post_ID. Let's go back to the code. I change the position of current_post_ID and make it more global within the frontend. Then I execute the code again and test directly from the notebook to save time. I log in as ktips, submit a comment, and then click again on the comment button to check the status of the last request. This time there's no error, but the post_ID is still empty. I try submitting a comment on another post. Same issue. I simply cannot reliably store the ID of the post associated with the comment button that was clicked. At this point, I insert several comments across multiple posts and inspect what's happening in the MySQL database. Interestingly, everything looks correct there. We have both the user ID and the post ID properly saved. We can even double-check the post table and see that post IDs go up to 20, 27, 30, everything looks normal. So the relational database side is behaving as expected. This confirms that the issue is isolated to how the comment button interacts with the frontend state and how that state is propagated to Milvus. At this stage, things are getting a bit messy. So I decide to reset everything. I completely wipe all my MySQL tables and reinitialize them. It's frustrating, but it's also a signal that I need to restructure my code to prepare it for becoming a real application. This will also make debugging much easier. I also re-execute my Milvus setup code. And at this point, I decide to stop day 3 here. There's clearly some fatigue and frustration setting in, and pushing further wouldn't be productive. Let's do a quick recap of what we've implemented today. Day 3 of this challenge was actually spread over several days. I'm developing this project while working full-time, so I usually invest about 3 to 4 hours each evening. But some days are heavier than others, and today was clearly the most challenging one so far. We did encounter several bugs, and some are still unresolved, but that's okay. I'll fix them tomorrow before starting day 4. So what did we achieve today? We configured a MySQL server. We configured Milvus for the first time, at least for me. We implemented functions to insert new records into both databases. At this point, you should clearly understand the difference between these two types of databases. Traditional databases like MySQL are not competitors to vector stores. Vector databases are designed for entirely different use cases, especially semantic search. Speaking of semantic search, this is the core of our application, but it hasn't been implemented yet. I'll tackle that on a day when I'm more rested. For now, we already know how to perform other types of queries on our databases. The comment insertion into Milvus didn't go smoothly, but we now understand the problem much better, and we'll fix it. Tomorrow, in day 4 of the challenge, we'll introduce pedantic models to validate our data. We'll update our insertion functions so that data is written to the databases only after it has been fully validated. This will prevent many of the type-related issues we've been encountering. For example, you might remember the function, where we explicitly ensured that the output from the language model was valid JSON. With pedantic, we'll extend this approach to all incoming data. This was a very long video, and if you made it all the way to the end, thank you, and congratulations. I'm confident you learned something valuable. Remember, this video is part of a larger and very exciting series, and there's much more coming. To make sure you don't miss what's next, I invite you to subscribe to the channel. It also really supports my work. And if you haven't already, don't forget to like the video. I'll be very happy to see you again in day 4. Until then, happy coding and debugging with K-Tips. See you in the next one.